Hey everyone, good morning, and welcome to Fighting for Five, episode 4, where we go over the document problem number 4. So this problem dealt with one of the topics that we learned very early on, and that is describing a distribution of quantitative data. All right, so looking into it, the data that we're analyzing here are distances that a ping pong ball is launched in centimeters. And we actually have two distributions of data. We have catapult A and catapult B. And the task, of course, will be sort of to compare these distributions and then sort of make decisions based off of the distribution that we're seeing. Okay, a little bit of technical difficulties there, but we're back. Now, as you can see, I wrote out a bunch of the information that I'm going to use in part A, but one of the concerns from students was, do you have to use exact values? And the answer to that is yes, you do, because when we're given something like this, which is a dot plot, you have the exact information. And so when you're describing things like center, when you're just describing quantities like the center and the spread, you should give exact values and not just approximations. On the left in the blue, you see my calculations for outliers, and it turns out that catapult A does have outliers. However, as you'll see in my answer, I don't actually mention the outliers because it's not a requirement. I'm doing this just to let you know that if you do say that there are outliers, make sure that you have verified that indeed they are outliers. Sometimes gaps, so sometimes there are like extreme values that may be outliers and may not be. And if you say that they are outliers when they're not actually outliers, you might get points deducted for that. You might be penalized. So just be careful. Anyway, I just want to talk about let's get right into the problem. So part A, comment on any similarities and any differences in the two distributions of distances traveled by balls launched from catapult A and catapult B. The important thing for a problem like this is to understand that we're not just looking for two separate lists of statistics from these two catapults. What we're interested in is a comparison of those statistics. So we need to use compare words like greater than, less than, equal to, something along those lines. All right, so here's what I wrote. And of course, since we're describing quantitative distributions, we want to touch upon center, spread, shape, and unusual features. All right, so for center, I said something very simple. Catapult A's median distance is less than catapult B's median distance. And I underline less than because that is the compare word. All right, so this shows that I'm linking these two distributions together. I'm actually comparing them. I then also mentioned the exact values, 136 centimeters versus 138 centimeters. So notice that this answer has context, it has exact quantities, and it has compare words. All right, going on to spread. I decided to use the IQR, although since both of these distributions are fairly symmetric, using the range, just the standard range, would have been fine as well. But I said for spread that catapult A's IQR is greater than catapult B's IQR. And once again, I listed the exact quantities, 4.5 centimeters versus 3 centimeters. Keep in mind that you should know how to calculate an IQR if you're given a distribution of quantitative variables. Yes, your calculator can help you find Q1 and Q3, but in a situation like this, it would probably take a long time to type all of the data into your calculator. So try to do it by hand. Remember, Q1 is just like the median of the lower 50%, and Q3 is the median of the upper 50%. All right, and if you need to pause the video here and sort of just see how I calculated Q1 and Q3, just count the dots. All right, shape. Now, shape is a little tricky. Looking at these, I could see you arguing for bimodal for catapult A or unimodal. I'd be fine with either, and I believe the AP was fine with either. Both of these are more symmetric than not, so I don't think it would be good to argue any sort of skewness. All right, so you should argue symmetry for both. Anyway, I went on and I said that both catapults seem to be fairly symmetric, but A can be described as bimodal, whereas B can be described as unimodal. So yeah, my interpretation was that A was bimodal. I saw sort of like a hump up here and then one over here. So that's where I'm getting my bimodal argument. But if you said unimodal, it probably would have been fine. But notice that I touched upon two pieces of information. I touched upon symmetry / skewness, and I touched upon modality. So when you're describing the shape, you must describe these two items. All right, it's not enough just to describe the shape as being symmetric or skew, and it's not enough just to describe the shape as being unimodal or bimodal or whatever. You must describe both for shape. And as far as unusual features, catapult A has large gaps from 122 to 129 and from 148 to 155 centimeters. Now, again, it's not enough just to simply say that there are gaps. You should be specific about where those gaps exist. And then I went on to say that catapult B has no large gaps. Now, notice that when we get to the more qualitative descriptions, such as shape and unusual features, I can't really say like less than or greater than. So I'm doing my best to compare these by making a statement about catapult A and then saying, whereas catapult B, blah, blah. So with the more qualitative descriptions, such as shape and unusual features, do your best to sort of make it obvious that you're comparing these two distributions. All right, moving on. Part B asks, if the parents want to maximize the probability of having the ping pong balls land within the band, which one of the two catapults would be better to use than the other? And then, of course, you have to justify your choice. All right, so I mean, technically, you could probably choose either one as long as you have a convincing argument for either one. However, in this situation, there's one pretty obvious choice. And just looking at the distributions, it's pretty obviously catapult B. Now, the specific argument, because really the idea is, remember, the whole goal of this challenge is to land as many ping pong balls in this gray band. And so you're looking for precision, right? And catapult B seems to be more precise because of the fact that the spread is much smaller, the smaller IQR, the smaller range, no gaps really. All right, so all of these are arguments for catapult B. I can't really think of any really good argument for catapult A, to be quite honest with you. But in general, with a question like this, there's not necessarily a right or wrong answer as long as you do have appropriate convincing evidence. Anyway, moving on, I went on to say that the parent would be wise to choose catapult B. This is the more consistent catapult. All right, so I make that statement and then I provide evidence, as evidenced by the lower IQR and the lack of gaps. Now, I didn't go on and restate the IQR because I had stated it just before in problem A, but if you're looking to be perfectly safe and if you have time, it wouldn't hurt to restate the IQR. Okay, there's that. That was pretty quick. Part C, using the catapult that you chose in part B, how many centimeters from the target line should the catapult be placed? Why would you choose this distance? All right, so here you have to state a specific quantity, and then you have to justify that specific quantity. All right, and I went on to say that I would place catapult B 138 centimeters from the target line. All right, so that's where I would place it. Why? The reason is that 138 centimeters is the median, and if we go 2.5 centimeters above and below 138, you should be able to land about half of the ping pong balls in the band, and that is according to the distribution. So 2.5 centimeters above and below, where do I get that? Well, since the band is 5 centimeters in, let's say, in radius, then that means we're talking 2.5 centimeters below the target line and 2.5 centimeters above the target line. So that's where that number comes from. And if we take a look at the median, if we go the 2.5 to the, if we go 2.5 above and 2.5 below, we end up capturing 10 out of the 20 ping pong balls that were thrown in the sample. So that's where I came up with the statement that says you should be able to land about half of the ping pong balls in the band according to the distribution. So notice that each of these statements, I'm not just stating them and moving on without any sort of factual evidence to back it up. Uh, I'm stating things that can be easily backed up by the information that we're given. And so that's one thing you want to keep in mind. On the AP, your answers should not be detailed novels. They should be sort of short to the point and backed up with evidence. Okay, like you see here. I know that this looks like I wrote a lot because I write large and fairly messy, but realistically, this is just one sentence. So, but notice that within the sentence, I have context, I have specific information, I have statements that I'm backing up with that specific information. All right, so that's what you should try to strive to do. All right, folks, thanks for listening. Thanks for watching, and I will talk to you soon. Take care. Bye.